Hi, all of you. Welcome back. My name is Adil. I'm your chemistry teacher in Base Education Services Private Limited. This is our second session for bridge course or introductory course for your standard 11th. Last class, we discussed about introduction of chemistry and I have given you some homework. So let's clear up that first and then we will move to today's session. So the homework which was given to you yesterday was name two toxic metalloids. So the answer is arsenic and polonium. One of this I already informed in the lecture yesterday when I took, and polonium is the new one which you need to find out. I hope that part is clear. They are the most toxic in metalloid family. Name most electronegative elements. So the most electronegative element will be definitely a non-metal because they have the capacity to gain electron. So it is a fluorine, and a fluorine on Pauling scale, there is a scale which measures electronegativity. The value is 4.0. Okay, this later also we'll do, so no problem at this point. Name a lustrous non-metal. A non-metal which you cut, it must have shine. So graphite or iodine, you can tell. Either of these will be the answer. But majority of the book goes with iodine. So let's go with iodine only. Next, name a metal which is bad conductor of electricity. It is lead and bismuth. You can write any one of this, but lead is most frequently seen in our books, whatever we have for chemistry. And last, why solids are non-compressible? Answer is the constituent particle. Constituent particle means the atom or the ions, whatever it has, are tightly or closely packed. So since due to that close packing means this, there is a very less available space. So when you try to compress it, it will not undergo compression at all due to tight or close packing or less availability of the holes or the voids in between them. So the gaps in between them is known as voids. So these are the 5 questions of the last session. I hope most of you have answered it and understood it. So let's move to the next session. So this is your session number 2 in bridge course of chemistry. So today we are going to discuss about valency and the formula of the compound, how to write basically the formula of the compound. Some of the students feel difficulty, so this session will be a help for them to understand that part very much in crystal clear form. Now, before I go inside this, let me take you to background. You know water. Whenever you tell water, you write water in English like this. In Kannada, you call it as neer, and Hindi, you call it as jal. But the chemical formula of water is H2. So whether you are in India or you go to Uganda or you go to Kashmir or you go to Laos, any place, the formula of water remains same. It is H2O. Now, ever it comes into your mind why the formula of water is only H2O? Why we cannot write it as HO? Why we cannot write it as HO2? Why we cannot write it as H3O3? This must, for some of us, this query must have been arised in our mind. The answer for this is valency, which we are going to discuss in today's class. Okay. Now, always we talk about bond. There is a bond. For example, there is a bond between you and your sibling. Suppose you have a brother, then you and your brother have a bond. You and your mother have a bond known as son and or daughter and mother bond. Father and mother has a bond known as marriage. Grandfather and grandmother also had a bond. So always we talk about bond. The question arises, why bond formation take place? Okay. The major question India wants to know, why bond formation takes place. So bond formation takes place because atoms are always in the constant struggle to become stable. For example, if I have H and I have Cl, individually they both are unstable. Unstable, why I will tell you later. So what they do, they come on a mutual consign and they form a bond between them. So this bond make both of them stable. Question arises, what make them stable? So stability comes on the number of electron what they have in their last shell, means their last shell. If suppose there is one shell, shell is nothing but the home of electron where electrons are present. If there is only one shell, then 2 electrons is required to make it stable. So this is known as doublet, which we will do in chemical bonding, doublet. If suppose you have 2 shell or more than 2 shell, plus is more than 2 shell, then 8 electron must be there in the last shell or the valence shell. This is known as octet, doublet and octet. If any atom has this, when the cell is more than 1, then it is known as stable. And when it has 1 cell, 2 electron, then it is stable. Now, due to this, in order to achieve 2 valence electron in the last shell or 8 valence electron in the last shell, the atoms continuously gain electron, lose electron or share electron. Again, in order to become stable, there are many atoms which gain electron, lose electron and share electron. But at the same time, there is a group of elements known as noble gases. So neither they lose electron, nor they gain electron, nor they share electron, because they are stable in itself, because they have, helium has 2 electron in its outermost shell and other one is having octet in their outermost shell. So all the bond formation, what we see is due to the sharing of electron to reach stability. That is the major concept what we have. If I give you an example, in organic chemistry, at present, we know around 9+ million organic compounds. 9+ million organic compounds are known only in organic chemistry. How it is possible? It is only possible when there is bonding, and that bonding arises due to sharing, transfer, or gain of electron. But in organic chemistry, majority of time there is sharing of electron. So we'll not go there. So what I want to tell you before I go into the session, that atoms are always in constant struggle to become stable. What decides the stability? Presence of 2 or 8 electron in their outermost shell, 2 when the shell number is 1 and 8 when the shell is more than 1. And after that, to gain this, either 3 things is possible: lose, gain or share. So that's what in background you need to know, that why it takes place. For example, if I take hydrogen, the symbol of hydrogen is capital H. It has 1 electron because atomic number is 1. And it has 1 shell only. So you write hydrogen like this. This is the nucleus and this is electron. So 1 electron, suppose here. It is not stable. So what it will do, it will either gain electron or it will share electron. Loss electron is also possible. In that case, it will become highly unstable. So suppose there is a hydrogen with 1 electron and it will form a bond with neighboring hydrogen with 1 electron. So they mutually share it. So this is mutual sharing of electron. And when 2 electrons are shared, 1 bond is formed. That's why we write as H2. So in this case, there is sharing of electron, what we have seen. Now let's take example of oxygen, atomic number 8. So we write electronic configuration as 2, 6. It has 6 valence electron in the outermost shell, which is not stable. In order to become stable, it must have 8 valence electron because there are 2 shells, A and L shell. So 8 valence electron is required in the last. So what it will do, it will gain 2 electrons on itself. So in this case, since 1 electron is involved, I can tell the valency is 1. Here 2 electrons it gain, I can tell the valency is 2. Let me take one more example, then we'll come back to our topic, magnesium. Magnesium is 12 atomic number, so 282. Now it has 3 shell, that is K shell, L shell and M shell. This is the name of the shell which is given. Basically it is, in layman term, you can tell it's a room where electrons are present. Now this 8, this 2 is making it unstable because This is not the first shell. That's why you will not be getting confused with a doublet. Since shell is more than one, it must have octet. So it has to gain 6 electron to become stable. But who will give the 6 electron? And gaining 6 electron by taking from someone require a lot of energy. So it will not gain 6 electron. It will easily lose out 6 electron. So when it loses 6 electron, you can tell the valency is 2, because after loss of 2 electron, it becomes 2,8. 8 means stable. So this is a bit of just about what is valency. Valency is something, valency you will come to know when electrons are lost, gained, or shared. Now let's move inside valency and check what it is. So what I explained, that bond formation is decided by valency. So keep that into mind. So valency is what? It is the combining capacity of an element. So remember this definition. It's a CC of an element, combining capacity. Now, valency you can define or explain in the couple of new ways also. So now I am explaining with respect to hydrogen and chlorine. In the next slide, I will explain with respect to oxygen also. So in terms of hydrogen or chlorine, the valency is defined as the number of hydrogen and chlorine atoms with which an atom of an element combined. For example, if I take sodium hydride, and I asked what is the valency of sodium, so how many hydrogen is present in it, because it is tell us the number of hydrogen of chlorine. So we can tell that the valency of sodium, since hydrogen is 1, valency will be 1. At the same time, if I take magnesium hydride and I ask what is the valency of magnesium with respect to hydrogen, so magnesium, since it has 2 hydrogen, the valency is 2. Same thing with chlorine. Suppose I take sodium chloride as your table salt. So with respect to chlorine, what is the valency of sodium? So we write valency of sodium as 1. V means valency. If I take magnesium chloride, then I tell the valency of magnesium at this point of time. Since there is 2 chlorine, it will be 2. If I take aluminium chloride and I ask what is the valency of aluminium, the answer is 3, because 3 chlorines are there. So valency, you can talk with respect to your hydrogen or chlorine. Okay. With respect to oxygen also you can talk. Now in terms of oxygen, valency is twice the number of oxygen atom. So remember this, that was single unity. It is twice the number of oxygen atom with which an atom of an element combined. So let me give you an example of aluminium oxide. So Al2O3. Now here 2 aluminium atoms are there and there are 3 oxygen atoms. So 2 atoms of aluminium is combining with 3 atoms of oxygen according to the formula what we have, right? Right. Now if from 2 I come to unity, unity means 2 to 1. So 1 atom of aluminium will combine with how much? It's just like this. If 10 rupees you can buy 10 chocolates, then 1 rupee you will buy how many chocolate? It will be 1. Same logic we have applied. So 2 atoms of aluminium combined with 3 atoms of oxygen. 1 atom of aluminium is combining with 1.5 atom of oxygen. Okay. So valency of aluminium will be what? The definition tell it is twice the number of oxygen atom. Now how you can relate? You can relate like this. It was 8. So this is 2,6. Now you remember it gained 2 electrons. Okay. So from there you can relate this. So twice the number of oxygen atoms. So valency of aluminium will be 2 into number of oxygen atom. So 2 is there, and the valency with respect to 1 aluminium is 1.5. So 2 into 1.5 you can write it as 3. So this is the way you can find out the valency of aluminium. And later I will tell you that aluminium is atomic number 13. So you write as 283. So to become stable, it need 5 electron, but who will give 5 electron? It requires more energy. So it will lose 3 electron and the valency become 3. So it satisfied that way also. I hope this part is clear. So valency is combining capacity of an element. It can be defined with respect to hydrogen and chlorine and even with oxygen. Oxygen, be careful, it becomes twice the number. That's it. Clear? So let's move to the next topic, which is connecting valency only. It is known as radical. In chemistry, you get confused between ions and radical is there in biology also. So don't get confused with that radical, which you will read in the plant part. It is present in the root if you remember radical part. So radical basically is what? When you talk about radical, suppose I have a group of friends. I have suppose 3 friends. Yesterday I told you I have a friend Ashutosh. So with that I have one more friend Abhishek and one more is there as Abid. So we 4 are close friends. We are friends because we are compatible. Compatible means suppose I like suppose I like Counter Strike. They also like Counter Strike. Suppose the movie which I like. Suppose I like the movie which is not fiction, which is reality. They also like that. Suppose I like a novel to read which is having some logic behind it, they also like. Then only friendship will run. If suppose I like to see a movie like which is not science fiction, and if they like science fiction, then our comparatively not match. So radical is also like friends only. Okay. So basically it is what? It is a group of atoms. Radical is a group of atoms which can be of same or different type, okay, which combine chemically and act as a single unit with positive or negative charge on it. Again, radicals are group of atom with similar or different type of atoms which combine chemically and act as a single unit with positive or negative charge on it. Now, same definition I would have given you yesterday in case of your compound. But in compound, I would have not told that it carry positive or negative charge. That is a difference. Compound is neutral. Or another way to define radical is a group of atom with a charge that would take part in chemical reaction as a whole. For example, if I write ammonium radical, so this is your NH4 plus ammonium radical, the positive charge is present here. So in this case, the valency will be what? So the valency of the radical is equal to the positive or the negative charge present on the radical. Since one positive charge, so the valency of ammonium ion is NH4 plus is 1. So ammonia is NH3. It become ammonium. Okay, anything which has positive charge basically ends with IM. Okay, so ammonium is your positive radical valency 1. At the same time, if you write it as sulfate, that is SO4 2 minus, the valency here is your 2. And remember that this charge is spread all over the atom, whatever is present there. It is not individually carrying at this point of time for you. Same if I write oxide ion, so hydroxide ion, I will write like this, valency is 1. If I write H plus ion, then the valency is again 1. For example, if I write Cn minus, so the valency is again 1. So on radical, whatever charge it has, irrespective of that, the valency will be equal to its magnitude. For example, 3 plus. For example, aluminium is having 3 plus. So the valency of this is 3. So charge-wise, we are not writing. We are just writing the number what is present there. So this is in short introduction about radical. Again, I will tell it is a atom or group of atoms which can be similar or different type, which combine chemically as a single unit, or you can tell single entity, carrying both positive and carrying either positive or negative charge on it. Got it? Good. Now, one thing extra I will explain you here. Try to understand this. I cannot change. Okay. Now, always you will hear the word sulfite and sulfate. So phyte and fate, ITE and ATE. So ite means what? SO3 2 minus, and 8 means was just now you have seen SO4 2 minus. How to identify difference between them? Sulfite and sulfate, ite and 8. Ite will have lesser number of oxygen, 8 will have more number of oxygen. So 8 has 4 oxygen, 8 has 3. Similar to this, you can write it as nitrite and you can write it as nitrate. So nitrite is NO2 minus and nitrate is NO3 minus. So less number of oxygen in 8, more number of oxygen in 8. This part is clear? Very good. Next, move to the acid and basic radical. Okay, we are going to discuss about acid radical. Now, you know what is radical now, so I'm writing R circle. So acid and basic radical. Now, before I give you classification, because this chart and the chart in the next slide, which will help you to derive the formula of a given compound. Without this, it will be difficult. That's why we felt that we need to give you this because if some of you have difficulty in writing formula, then you can learn from here and come back to the class fresh when we start. What is acid radical? Basically, acid radical it is negatively charged, carrying a negative charge. Basic radical is basically carrying a positive charge, negative charge and positive charge radical. Acid radical is formed by the removal of H plus ion. So it is formed by the removal of H plus ion. When you remove H plus ion, it is formed. And basic radical is formed by the removal of hydroxide ion, OH minus ion removed. This is a very basic difference between them. For example, I have HCl. When I remove H plus and Cl minus, then Cl minus is your acid radical which is formed. It is only formed when H plus is removed. Or I take it as HNO3, that is your nitric acid. This is one of the strongest acid what we have, nitric acid. So this will be H plus and your NO3 minus. This will give rise to your acid radical. Basic radical example, when you take, suppose you take it as potassium hydroxide, so it will form K plus and OH minus. So this K plus is acting as your basic radical. Or suppose if I have calcium hydroxide, so you remove OH, so it becomes Ca2 plus and OH minus 2 times. So this is your basic radical. So remember that acid radicals are negative, formed by removal of H plus ion, which is also known as proton. And basic radical is positive radical, and it is formed by the removal of OH minus ion. This is the basic difference at this point of time, only this much. When you come back to us, we will explain more in depth. Now the formula of the various basic radical with their valencies are given below. So this, in chemistry, my dear friends, students, you need to memorize close to 3 to 5% of the subject. For example, you need to memorize periodic table as much possible. You need to memorize few of the radicals. You need to memorize few of the rules. But other than that, in base, we will teach you how to approach that problem with logic. But some memorization is required. For example, in English, you memorize alphabets A to Z. Then you can write elephant, owl, donkey, monkey, crow, curd rice, biryani. You can write that, right, the spelling wise. Same way, here you need to know all this. It has no logic behind it that without knowing this, you can arrive at the formula. So you need to know this. So I suggest that practice this 1, 2, 3, 4 times. Make a chart of this and place in your reading room, paste it either on your cupboard or the wall or the door, and every day see once, and trust me, you will become genius in this. So the basic radical basically the positive entity, and which is formed by the loss of H plus ion. So 4 types of basic radicals can be there. Monovalent having 1 positive charge, divalent having 2 positive charge, trivalent having 3 positive charge, tetravalent having 4 positive charge. So there are more than this, but this much is more for you. Here also some of them are not required, but still I have kept just for your knowledge. So monovalent is proton H plus, lithium ion, Li plus, sodium ion, Na plus, potassium, cesium, copper, silver, ammonium. This all you have to know. Then you have beryllium, magnesium, calcium you need to know. Then you need to know cuprous, zinc, ferrous. Others are just for your knowledge. Aluminium is famous, Al3 plus. Ferrous is there, Fe2 plus, so ferric is here. Chromium was there, and chromic is here, Cr3 plus. Then you have platinic, that is Pt4 plus. Couple of more are there, but we don't go there at this point of time. You are too in nascent stage to know this. So please remember this. Write this separate in a kg cardboard sheet or the A4 size paper with color pens. Use color psychology, and see the miracle will take place. So this is basic radical. Let's move to your acid radical. So acid radical, again, it is of three types. We are taking monovalent with 1 negative charge, divalent with 2 negative charge, and trivalent with 3 negative charge. Tetravalent, rare, but we'll teach you when you come back to us. At this point of time, no. So fluoride, chloride. Now how fluoride we got, I will tell you that. Fluorine atomic number is 9, so this is 2,7. And this is 2 shell, K shell and L shell. Since 2 shells are there, the valence electron must be 7. And the valence electron stability must be 8. So what it will do, either it will lose 7 or gain 1. Losing 7 require more energy. Why it will lose? The logic is not there. So it will gain 1 electron. The moment it gain 1 electron, it becomes 2,8. And electrons are negative charge. Okay, students. Electrons are negative charge. If you gain negative thing, you will have a negative charge on yourself. So what it will have 1 negative charge. If you gain 2 negative, then 2 negative charge. Let me give you example of oxygen, that is 2,6. It gained 2 electron. The moment it gained 2 electron, it becomes 2,8. The moment it becomes stable, it will have 2 negative charge. So from that only you will get the negative charges. Positive charge is due to loss of electron. Negative charge is due to gain of electron. So bromide, iodide, nitrate, just now I informed you nitrate and nitrite, hydroxide and hydride. Hydride is interesting. Proton, see hydrogen is H, having 1 electron. H plus 1 electron is gone, so it has 0 electron. Hydride is H minus, already it has 1 electron, it will gain 1 more, it has 2 valence electrons. So it can be neutral also, it can be positive also, it can be H minus also. This is known as hydride. Hydrogen carrying negative charge is hydride, H plus is your proton. Then bivalent, it is oxide, I have shown you. Peroxo, you leave it, we'll do it later. Carbonate is there, CO3 2 minus. Then sulfate, sulfide, and sulfide, IDE. See here it is 8, ite, and ite. So just remember this. It will help in coming days. Then trivalent nitride, let me explain you this. Nitrogen is capital N, 7, atomic number 2,5. K shell, L shell. L shell means 2 shells are there. In order to become stable, it must have 8 electrons. To become 8, it needs to gain 3 electrons. So the moment it gains 3 electrons, it becomes 2,8. Now stability is there according to a rule known as octet rule. Octet means 8. And this has gained 3 electrons, so 3 negative charge. Just like aluminium has lost 3 electrons, 3 positive charge. Here it has gained 3 electrons, 3 negative. Same thing is with phosphate and phosphide. Just for your knowledge, you keep it with you. We will discuss this in coming days. I believe both the charts are clear. Now I suggest you write that chart also and this chart also and go through it. Now pause the lecture and write both of them. Then let's go to the next one. Okay. So pause the lecture and then let's move. I hope it is done. Now, always we get confused when I tell ferric, ferrous, cuprous, cupric, aurous, auric, stannous, stannic. Why this ic and us? So remember that most of the element shows variable valency. Variable valency means they can have 1 also, 2 also, 3 also, +1, +2, +3, -1, -2, -3, like that of stuff. But for positive radicals, which carry positive charge, for them, lower valency ends with us and higher valency ends with ic. So I'm giving you a cheat code to remember. Remember low us. Low us means lower ends with us, or you can write high ic. Hike, you know, let's go for mountain hike or hike of price, anything. So lowest and hike, lowest means lower is Us and higher is ik. So that's why copper has two. It is cuprous and cupric. So cuprous is +1 and cupric is +2. Higher is +2. Ferrous and ferric. Ferrous is Fe2 plus and ferric is Fe3 plus. Aurous and auric. This you will find out. Everything I will not give you. Au what? Au what? Okay. So cuprous, cupric, ferrous, ferric. You just remember that lower valency ends with us and higher valency end with. Lower valency ends with us and higher valency ends with ik. Clear? Very good. There are many more, but I have, due to time constraint and all, I kept it less. We will do much in detail in class. Now, how to write formula of the compound? So there are a few steps which you need to follow. Formula of the compound. The formula of the compound can be obtained by these 4 golden steps. So step 1, first step, you write the name of the organic compound and keeping in mind metallic part first and non-metallic part. So magnesium nitride. We don't write nitrite magnesium, but magnesium nitride. The metallic part first or the positive part first and then the negative part. We always love to have positivity in start. Okay. Just a layman term, but metal you write first, then forward by your non-metal or the non-metallic part. Then the symbol or the formula of the elements are written. So whatever symbol or the formula you can relate, you can write. So magnesium is there and nitrogen is there, you write that. Now you know that magnesium is atomic number 12, so it is 282. The 2 valence electron which is not stable. Nitrogen is 7, so 2,7. Now this will do what? It will lose 2 electron. And this will do what? It will gain 2 electron. So when it loses 2 electron, magnesium electron is negative. So 2 negative things are lost to 2 positive charge. And nitrogen here is, sorry, 2, not 7 it is. Nitrogen is 7, so 2,5. Sorry for that. So here it is losing 2 electron and here it is gaining 3 electron. Sorry for that. It gained 3 electron. So it will have your 3 positive charge. 3 negative charge. So magnesium is losing 2 electron. That's why 2 positive. Nitrogen is gaining 3 electron. So 3 negative. So valencies are +2 and -3. So third step, write the valency on each indicated on top. So magnesium, you don't write plus, and nitrogen don't write negative, only write the number. So 2 and 3. And step 4 is intervalency rule, do the crisscross. So magnesium, nitrogen. So magnesium was 2, nitrogen was 3. Either you can write on top or even you can write in bottom. So this will move this side and this will move this side. So when it moves, you get Mg3 and N2. This is the formula of magnesium nitride. I hope that is clear. So there are 4 golden steps. First step, write metallic part first, followed by non-metallic part. Second, write the symbol of the elements which is involved in that. Third, write the valency of that either on top or the bottom without the signs, positive, negative. And last, do the intervalency. You exchange them and you will arrive at the formula. I hope this is clear. Please go through it 3-4 times, fit in your brain. It will help you a lot in the coming days. Let's see a few more examples. If I take calcium chloride, now calcium is what? So calcium is atomic number 20. So this is 2, 8, 8, 2. Okay, 7, 8, 16, 17, 18, 20. So 2 means it's a metal, it will lose. So it will have 2 positive charge. Chlorine is 2,7. 7 means it needs 1 more electron. So it will gain 1 more electron. So -1. So 2 on top and 1 on top, do a crisscross, you arrive at calcium chloride. Okay. Same thing with ferric oxide. Ferric I have just now given higher oxidation state. So Fe3 plus electronic configuration. I don't want to tell you now for iron because it is D block. It is huge. You don't know that. So I am going with ferrous and ferric concept. And oxygen is your 2 negative. Avoid the symbols, signs, and do the crisscross. So when you do crisscross, Fe2 here and O3 here. Sodium oxide, you know sodium is 281. It loses one electron, so one positive charge. Oxygen, so many times I told you, now it is two negative charge. So you are writing 1 and 2, doing an exchange between them, sodium oxide. Zinc oxide, zinc is 2 plus. I'll tell you this later, the depth electronic configuration also 2 minus. So don't write the charges, avoid that. So ZnO, exchange it. Now 2 are common, so you can simplify this and write it as ZnO. The two atoms are in ratio 2:2. It has to be reduced to the simplest ratio of 1:1. Knowing the valencies of the radical, the formula of the compound can be arrived. For example, if you have an element X and you have an element Y and this is 4 and 2, suppose, then you can cut this and write X2, Y1. Suppose you have a valency in which X is there as 5 and Y is there as 15. You can make it a simplest ratio and write XY3 also. So you have to arrive at the simplest ratio possible. Okay, without in that. Very good. Let's move to the next slide. So you have questions. Write the formulas of the following compound. So 10 compounds, 10 molecules I am giving you. So go back, revise again, come here and solve it. Pause the video, revise it. I am giving you a couple of seconds. You will be solving with me. Understood? I hope revision is done. Okay. Write the formula of the following compound. Let me change the pen color. So write the formula of magnesium oxide. So magnesium, my dear friend, it is Mg2 plus and oxygen is O2 minus. What I will suggest, memorize periodic table till first 20 element at this point of time, from hydrogen to your calcium wala part. Even more also, if you can do till zinc and copper, well and good. So when you do this, you will arrive at magnesium oxide. Good. Ferric chloride, Fe3 plus and Cl minus. So you will arrive at the formula FeCl3. FeCl3 is right because it was Fe3 plus. So 3 I will write. Cl minus 1 I will write. Do the crisscross. So FeCl3. Now in third one, phosphorus pentachloride. Don't write penta at this point of time, because you can write it as phosphorus pentachloride is PCl5. I want you to write phosphorus trichloride. So if you write phosphorus trichloride, then phosphorus is atomic number 15, 285. Okay, so it needs 3 electrons. It gained 3 electron and become 3 negative. Chlorine is 2,7. Sorry, this part, or let me go like this for you, phosphorus, because valency part I have not done above this much, so I am not going there. You remember that phosphorus valency is 3 and chlorine valency is 1. So when you arrive at this, you will get PCl3. PCl5 was the previous one, what I said, phosphorus pentachloride. PCl5 is highly unstable. We'll do that later. Ammonium chloride, NH4 plus Cl minus. So they will 1-1 charge. So ammonium chloride, we will write NH4 plus. Don't make it like this and write it 1 and 1, because it will cancel out automatically. So ammonium chloride is NH4Cl. Then you have sodium bicarbonate. So sodium bicarbonate is Na plus, and bicarbonate is with hydrogen HSO3 minus. Carbonate is CO3 2 minus. When it gained 1 positive H plus, 1 negative charge come down, it becomes this. So they will exchange themselves. So NaHCO3, sodium bicarbonate. We will study in future where it is used, why it is used and all. Then you have copper sulfate, Cu2 plus, and sulfate is SO4 2 minus. So copper sulfate. Then you have silver nitrate, Ag plus, and nitrate is NO3 minus, AgNO3. Potassium permanganate, you have K plus, and you have MnO4 minus. Permanganate. Per means -1. If you write manganate, it will change. So this is KMnO4, purple color solution of crystals. Potassium dichromate. So potassium dichromate is K plus and dichromate is Cr2O7, and this is 2 minus. They will exchange. So K2 Cr2O7, orange color crystal, and form orange colored precipitate. orange color solution it will form. Sodium hydroxide is Na plus and OH minus, NaOH. So this is your base. So these all are the formulas of your various compounds which is given. So magnesium oxide, FeCl3 ferric chloride, phosphorus trichloride, ammonium chloride, sodium hydrogen carbonate, copper sulfate, silver nitrate, potassium permanganate, potassium dichromate. Why di? Because 2 negative charge, and NaOH. Now, keeping this into mind, the question of the day, I am giving you to write the formula of these 10 molecules. So yesterday I have given you 5 questions. Today I am giving you 10. Keeping in mind you will do a little more extra work. And tomorrow we'll discuss the answer of this. So that's all for today. So session number 2, we discuss valency. We discuss how to find out. We discuss radical. We discuss the formulae. By knowing the 2 charts of radical, acid and basic, we practice few problems, and this is your question. So if you had difficulty to write formula, I hope it is clear now. So if you see my video 1 time or 2 times this one, and make the concept concrete, solid. So when we meet in class, we are ready to go on the journey of chemistry. That's all for today. So take care of yourself, be safe, respect parents. Good night. Bye-bye.